Hello, good evening, everyone. So, welcome to the week fourth of the tutorial session of this course, Introduction to Robotics. So, this video will be also uploaded on the YouTube. So, if your students who cannot watch now can watch on YouTube, and if they have any doubt, they can comment there also. And if you watch the live session, you can ask your doubts in between as well. So, today we are going to solve some of the questions based on week 3 and 4, and we'll solve some of the numerical questions. And also, we'll see some of the basics concepts which are taught in this week in the NPTEL lecture. And all this video will be uploaded on YouTube and link will be shared in the NPTEL portal. So, we'll start with the first question. So, here in this question, it is given determine the Jacobian matrix for a four-axis SCARA manipulator for the given positions. So, in this question, it is asking the The Jacobian matrix for the given positions vector at px, py, and pz is the position of the tools with respect to the base. So when we have to find the Jacobian, basically the definition of Jacobian is given as in the lecture you must have studied. JKJ it means K is the kth row and J is the jth column of the Jacobian matrix that can be given as partial differentiation of WKQ divided by del QJ. So this means when you do it, it will be like del W1 by del Q1, del W1 by del Q2, dot, del W1 by del Qn. So on, at the end you will get del W6 by. Let's suppose K is equal to 1 to 6 and J is equal to 1 to n. So in this case, we can write the Jacobian matrix like this. So in our question, our position vector px that is given as n1 cos theta 1 that is c1 plus n2 c1 minus 2. Py is given as n1 s1 plus n2 sin theta 1 minus theta 2, and pz is given as d1 minus d3 minus d4. Okay, so in this, so now when we have to find the Jacobian, so we have to do del px by del theta 1. So in the first row, we can do here, when you do px by theta 1, you will get, and similarly you can do del py by del theta 1, del py by del theta 2, like that. So in the first row, when you do del px by del theta 1, so it will be, it is n1 c1. So differentiation of cos theta is minus sin theta. It will become minus n1 s1, and this n2 c1 minus 2. So the differentiation of this will be minus n2 sine 1 minus 2. Now when we will do differentiation with respect to theta 2, so the n1 c1 term don't have any theta 2 term, so it will become 0, and only the term will be remaining is minus n2 s of 1 minus 2. Okay, differentiation of cos theta is with respect to theta 2 is sine 1 minus 2, and after that minus n2 will come. Now when we differentiate with respect to theta 3, it will become 0 because there is no term of theta. Now when you do with respect to py, we will get n1 s1 will become differentiation of sine is cos, so it will become n1 c1 plus n2 c1 minus 2. When we differentiate with respect to theta 2, we will get n2 cos 1 minus 2, but here theta is in minus, so it will become minus of n2. So when you differentiate, it will become n2 sine of 1 minus 2, it will become cos of 1 minus 2. This question what is given. Similarly, for the last one, it will become 0, 0, minus 1, and 0. So there are four terms only. So this is the third one. So in this question, the correct option is the option number 2. This is the correct question for this. Correct option for this. Now moving on to the next question. In this question, it is asking at what angle theta 2 the manipulator attains the boundary singularity. So boundary singularity is attained when the arm is completely stretched. So whenever let's suppose there are three joints are there, so arms will be completely stretched. Let's suppose this is our base. So when this angle is 0 degree or either 180 degree. So because at sine 0, the value is 0, and sine 180 also the value of 0. So the arm will be completely stretched, and at that time the manipulator will be at the boundary. So the answer for this correct answer for this question is theta is equal to 0 comma pi. So at this value, it will attain the boundary singularity. This means the manipulator arm will be at the boundary. Generally, the dexterity value that is given as is equal to K1, K2, S2 in this question. So, if S2 is equal to 0, then it will attain the boundary similarity. Occurs when the tooltip is on the surface of the work envelope. Actually, this boundary similarity occurs when the tooltip is on the surface of the work envelope. It will be on the surface when this value will be 0. So this will be 0. Sine theta is 0 when theta is equal to either 0 or pi. So option C is the correct for this question. So now we'll move on to the next question. Like, what is the sufficiency condition for the existence of a closed loop solution? So there are two conditions. One, either the three adjacent joint axes are intersecting, or either the three adjacent joint axes are parallel. So in this question, the correct options are the three adjacent joint axes intersecting. Option 1 is correct. Three adjacent joint axes perpendicular to one another, wrong. Two adjacent joint axes are mutually parallel, wrong. Three adjacent joint axes parallel to one another. So these two are the correct option for this question. So now coming to the next question, like find the pseudo inverse of a matrix which is given, and this matrix is not a squared matrix. So generally, mm, for finding the we have to find the pseudo inverse for the matrix which is not a square matrix. That is also known as Moore-Penrose inverse or pseudo inverse denoted by B plus. This is also known as Moore-Penrose inverse or pseudo inverse. This is required when the Jacobian matrix is not a square matrix. So generally pseudo inverse is given as B transpose of B into B transpose inverse when M is less than N. This means number of row is less than number of column. And also this is equal to B inverse when M is equal to N. In this case it is a square matrix. So in this case M is equal to N, we can directly find B inverse uh, when determinant is not 0. The third one is BT B inverse into B of transpose. So this will be applicable when number of rows are greater than the number of columns. So in our question, this is a 2 cross 3 matrix. So in this question, you can see that M is less than N. So we have to use the first case where B plus is equal to BT into BB transpose whole inverse. So we'll solve using this. So B is 106, and after that in the second row it is 2 minus 1 0. So now our B, the inverse of the pseudo inverse, is equal to B transpose B into B transpose to the whole inverse. See, our B is 2 cross 3 matrix. So here B transpose is 3 cross 2. When you multiply these two, we will get 2 cross 3 into 3 cross 2. This should be 2 cross 2. and this will be inverse of 2 cross 2 will be 2 cross 2 only, and B transpose will be 3 cross 2. So after that, you will get the final matrix is 3 cross 2. Okay. So let's find this now. So when you do B of B transpose, first we will do this. So we will get 106, 2 minus 10 multiplied by, this will be equal to 1 plus 36, 37, 2 plus 0, this will be equal to 2, 2 plus 0, 2, 4 plus 1, that is equal to 5. So now we have to find the inverse of this. So when you find the inverse of B into B transpose, we will get divide the determinant and interchange the diagonal element and give the negative sign in the next diagonal element. So it will become 37 into 5, 185 minus 4, 181. So 1 by 181, just interchange it, 537, and give subtraction sign here. So this is the inverse of this BB transpose. Now again we have to do multiplication B transpose into this term. So our B transpose is 1 2 0 minus 1 6 0. Let's take here only. So after this we will get 5 by 181 and minus 4. So that is equal to 1 by 181. In the second term we will get minus 2 plus 74, that is equal to 72 by 181. Here we'll get 0 and then 2 by 181. This we will get minus 7 by minus 37 by 181. 30 by 181, and this will become minus 12 by 181. So this is our B pseudo inverse, that is equal to, so the correct option is when you divide this you will get 1 by 181, something like 0. Correct option is option B. Just to divide this by 181, you will get the answer. Do this using calculator. So there are also some properties of pseudo inverse. Like that is also very important. Like whenever like if A is a matrix, this pseudo inverse we can be find only if it satisfies two of these properties. So like A x A is equal to A. Yeah, let's suppose write in the terms of B So like if B is a n cross n matrix, then B plus that will be n cross m, and the dimension will reverse is the pseudo inverse of B if and only if it satisfies at least property 1 or 2. At least 1 or 2. Okay. So in this way, we can solve the question for the pseudo inverse. We'll move on to the next question. In this question, it is asking consider a roll pitch roll rest given below. So in this question, it is asking which of the statements are true. So five statements are given. Sorry, one, 2, 3, 4, 5, 6 statements are given, and asking which of the statement is true. So we'll see first statement: the waist has a singularity when theta 1 is equal to 0 degree. So theta 1 is rotating along. First, we'll see what is the correct statement, because in this it is asking which statements are correct. So we know that the dexterity is 0 when this theta 2, this value is 0 degree. Okay, or it is pi. So the should that dexterity is 0 when theta 2 is equal to 180 degrees is the correct, and also when theta 2 is equal to 0. So the correct option is B and E in this question. And also we can see the waist has singularity when theta 2 is equal to 0. Uh, at theta 2 is equal to 0. So theta 2 is equal to 0. The waist has singularity when theta 2 is equal to 0. And the dexterity is 0 when theta 2 is equal to 180 degree. So when theta 2 is equal to 0, the arms will be at the boundary. So it will give the singularity, boundary singularity. So option B and option E is the correct for this question. Now coming to the question number 9. In this question, dh parameters are given, and it is asking for the Cartesian manipulator. What would be the rank of the Jacobian matrix? So when we find the arm matrix, after finding the arm matrix, the arm matrix in this given question will be sin S4, C4 0 D2 0 0 1 and D3 plus L4. This will be the R matrix. So from here we can see this is our position in X, position in Y, and position in Z. So Px is equal to D2, Py is equal to D3 plus L4, and Pz is equal to D1. So now we'll find the Jacobians. So Jacobian is given as AQ and DQ. So AQ is associated with the linear tool displacement and BQ is associated with angular tool displacement. So here AKJ Q will be del of position vector. So first we will find AK now. So when we differentiate like here D2 with the second parameter we'll get 1 and other are remaining as 0. And after that Py D3 plus L4. So this is the third one will be 1, fourth one will be 0. After that it is 1, 0, 0, 0. And BQ is given as zeta k z k minus 1. And this is 1 when it is rotating axis, 0 when prismatic axis. Now our B will be, it will be 0, 0, 0, 0. So I will write in the separate. So Jacobian will be AQ and BQ. So you just combine these two, you will get the Jacobian. So the complete Jacobian is AQ and BQ. So this will be, This is our B. So here when we write, so this is our complete Jacobian. Here you can see there are four linearly independent vectors. So the rank four linearly independent vectors from the Jacobian. So the rank will be 4. So for this question, the rank of Jacobian matrix is 4. Now moving to the next question. Like in this question, the force values are given. Like what force would the joints have to produce if a static load of 0.4 x in x 0 plus 0.6 y plus 0.5 z with 0 nanometer moment is acting on the tool. Fk is the force applied on the joint K and Mk is the torque produced by joint K. So here our torque is equal to Jacobian transpose into F, where tau is the vector of joint force or torque, and F is the vector of tool tip force and moments. So F1, F2, F3, and tau 4. This is equal to our Jacobian transpose. So Jacobian transpose will be 001, 000, 1, 5 times 0, 0, 1. Let's suppose this is the Fx, Fy, force in all three directions, and Mx, My, Mz, the torque in all three directions. So when we multiply, we'll get is as, this is the third term, so Fz, comma, first one, so Fx, comma, this is the, sorry, here it will be 1, 0. So here we will get Fy, and at last we will get My. So in this question, Fz is given as 0.4, Fx, Fy is given as this, and Fz is given as this. So our Fz is 0.8. So F1 is equal to 0.8, comma, Fx is 0.4, Fy is 0.6, and My is 0 nanometer. So the correct option is 0.8, 0.4, 0.6, and 0. So option A is the correct answer for this question. So now we will do some similar kind of question again. So necessary condition to be satisfied for the inverse kinematics of a manipulator to be solved are, the correct options will be, the tool orientation is such that none of the joint limitations are violated. Yes, this is the correct option. And also the tool point should be within the workspace and degree of freedom must be greater than or equal to 6 to have any arbitrary orientation of the tool. If it is less than 6, then some orientation will be missing. So option A, C and D is the correct here. Now moving to the next question again. In this question, it is asking to find the Jacobian. So we can find like how we have found for the previous question. In this, the correct option is option B is the correct option. You can solve how we have solved the above question. Again, this is a similar kind of question. Here, S2 should be either 0 or pi for having the boundary singularity. But at 0 and pi, the arm will be fully stressed. Again, the similar question. So in this, the width has a singularity when theta 2 is equal to 0 degree. This we have already solved above. And this also you can solve how we have solved the pseudo inverse question. Like you can use the formula of pseudo inverse, and the correct option is option B is the correct here. So today we will end the lecture here only. So if you have any doubt, you can ask. And the students who have not seen this video can watch on YouTube as well. So thank you everyone.